everybody. My name is Stenver Jerkku, and I'm going to talk about RxJS and reactive programming. I'm from a small country in the north called Estonia. Maybe some of you have heard of it. Probably most of you not. So I work in a company called eAgronom, where I'm a CTO and co-founder. Previously have worked in SailMove, Tartu University, Nortal, CGI, and some other small places. And well, I'm basically a really big functional and reactive programming advocate. Wherever I go, I try to explain people that this is not just something that academics use. This is actually useful things that will make your lives easier, because it will make your code cleaner, more maintainable, more testable, and it's actually really useful tool that every decent developer should build into its portfolio. The other thing is that I'm a huge Dungeons & Dragons fan. So who here plays Dungeons & Dragons? Amazing, amazing. We have so much to talk about. I'm a dungeon master, been for like 10 years. So I know this game inside out. Let's talk about it later. For now, let's talk about reactive programming. So this is basically a story how we solved big asynchronous problems and removed state machines from our systems by thinking differently about events. I worked with applications which are heavily asynchronous. Everything you can imagine in these applications are asynchronous. The application startup, dependency loading, real-time communication with videos and stuff starting, everything is asynchronous. DOM manipulation, like imagine two people manipulating the same DOM in different computers, similarly to TeamViewer, for example. Everything is asynchronous. Data access, animations, view, model binding, you name it. Basically, we kind of got really good at dealing asynchronous problems because we just had so many asynchronous problems. So we were forced to learn how to handle these things. Asynchronicity is really hard. This is how I would describe asynchronicity. You know, you try to catch this water, but it's already out. Like, it's really easy to shoot yourself in the foot if you don't know what you're doing, if you're doing asynchronous programming. Who here is a JavaScript developer? Raise your hands. Most of you. OK, so you've all seen this. It's like callback hell, right? Our day-to-day business, we're all happy to see it every time we see it. It's callback hell is you just have functions calling all over the place. The function flow is not nicely from bottom to top or top to bottom or whatever. It's like you have to read around the place, and it's difficult to simply follow how the code works around. Another thing that usually comes with callback hell is state. Usually you have state defined somewhere, and the callbacks randomly modify the state. And it's really hard to track how the data flows, because state is being manipulated from random places. And this really causes bugs. It causes race conditions. It causes headaches, takes lots of debugging time, because it's state is simply not unidirectional, right? Another thing that callback hell really gives us is it takes away error handling. We developers love try catch, right? Because try catch is excellent tool for handling errors. You simply, exception comes, you handle the error, you do whatever you want. With callbacks, you don't have that luxury. You have to figure out your own error handling. And this is really hard, actually, because if you do stuff like that, it's really simple to cause bugs and miss something. The error handling is usually brittle, and it doesn't usually work out very well. And in this code, I purposely added a line which causes memory leak. This code basically starts an engagement between two people, and it starts their media, like video, and it preloads their DOM. And they can cancel the entire process by clicking this button. However, if the cleanup is not done after clicking the button, you have a memory leak. And if you do enough of these errors, then your application becomes bloaty, it becomes slow, and traditional imperative JavaScript programming makes it really easy to cause memory leaks in general. So one thing is to be just a really good programmer and notice these memory leaks, which is impossible most of the time. And second is to look for alternative solutions. So let's talk about reactive programming. Who here knows what reactive programming is? Raise your hands. There are a few people. Like, tell me in one sentence, what is reactive programming? Yeah, you.
It's something that you have a stream and that someone can observe, and when the stream changes, everything that observes this stream reacts to changes.
Okay, so it's something, he said that you have something that you have a stream, and when something in the stream changes, then all the other places react. I think that's one of the best things I've heard in single sentence. Somebody says, oh, thank you, that's really good. But I'm going to show you my story, how I learned about reactive programming. So basically, when I started learning about reactive programming, I went to the World Wide Web, the place where all the human knowledge is accumulated, and I found this picture. It has pull, push, have next, got next, but it doesn't tell me what reactive programming is, right? So I needed to dig deeper. Reactive Manifesto, I mean, this has got to tell me what reactive programming is. It's responsive, resilient, elastic, message-driven. That's what reactive systems are. There's arrows, boxes, and everything. Your project manager will love to hear this thing. But it doesn't really teach you what reactive programming is. So turns out Reactive Manifesto is actually useless in telling us what reactive programming is. You should have helped them build the manifesto. So let's go to Microsoft's definition. Microsoft is basically, they summarize it by saying that Rx is simply observables plus Linku plus scheduler. Now, I've written .NET for 2 years of my life, like 5 years ago, and this doesn't tell me anything. Maybe it tells to some of you, but for me, this left me puzzled. I didn't know what reactive programming is by reading that. Final attempt. Not final, actually. Let's check out Stack Overflow. This is a really nice, like this guy tried to say what reactive programming is, not in a single sentence. He tried to say it in 2 pages. And like the top post sums up his response perfectly. Like there's a top comment written to it. You sound really smart, but please repost in English. So from the API, there's a method called flatMapLatest. We use it all the time. It's super useful. It's one of the most useful things there is. And the documentation says an observable sequence which transforms the items emitted by an observable into observables and mirror those items emitted by the most recently transformed observable. Holy cow. I use this method all the time, and I don't understand what this says. OK, so let's talk about reactive programming. This is my attempt at explaining what reactive programming is. And let's try it out. So basically, reactive programming is programming with asynchronous streams. Can anybody tell me what an asynchronous stream might be? You can speak out loud.
Sequence of events.
Sequence of events. Very good. Anything else? Mouse clicks are also. Can anything else be a stream? Ah? That's right. I bet you have seen a similar speech already. Eric Meyer, one of the founders of reactive programming, asked that, what is the difference between an array and an event? Now, if you really start thinking about it, then fundamentally, both are collections. An array is basically a collection of items that exists. A collection of events is simply a collection of items that exist through time. not in the present moment. So the only difference is actually just the time factor that's counted in. So it turns out that if both events are fundamentally collections and events are also streams, then arrays are also fundamentally collections and are a stream. And since we know that everything can be composed of arrays, and arrays are streams, then everything can be treated as a stream. So it's really hard to wrap your head around this at first, and you need to kind of just have this click moment. But once you get it, you get this sense that everything is a stream. Variables, user input, properties, caches, data structures. It's all just like a stream of data flowing around. When you scroll down in Facebook, you get to the bottom. There's a stream of new newsfeed coming in. When your friends write to you, it's a stream of messages coming in. When you write back, it's a stream of messages going out. It's all just a stream flowing around. Doesn't matter if it's front end, back end, everything can be treated as a stream. And streams are actually really cheap. Since we know that the arrays are cheap, then streams are also cheap. And everything you can do with an array, you can do with the stream, because arrays are stream. And that's where we can get functional, because arrays have these nice things like maps, reduce, etc. Turns out streams have them as well. You can take one stream as an input and use that stream as an input to another stream. You can take two streams, merge them together, and have a third stream, like this. In this case, we have one stream, then we have another stream, but we merge them together into third stream. So we just put the stuff together, just like with an arrays, but through time. You can also concat streams. For example, in this case, we have two streams. They both complete. And then we concat them together. Just take the second stream, put it at the end of first. Now we have a third stream that's concated. Just functionally approaching streams the same way we would approach arrays. And all the other functional things you can imagine, everything you can do with streams, you can do with arrays. Streams are functional. They can be mapped. You all know what mapping is, right? I mean, even Java developers know by now what mapping is. Thank God. It's basically just taking a function and applying that function to every element in the list. So in this case, we turn all the ones multiplied by 10. Streams can be filtered. So we apply the function to every element in the list, and whenever the function returns true, we keep it. Otherwise, we filter it out. Simple filtering, functional, simple. They can be debounced. That's really important. Very nice feature of Rx. It basically means that if you have an event coming in, then you debounce it. You wait for a certain time before you accept it. Now that the second event comes, we wait, but another event came in. So we actually forget the first one. And we keep taking events until, again, we have that pause we wanted. So we get the pause, and then we only take the final element. The others are thrown away. And the sixth one, pause, we take it. It's helps you solve a lot of asynchronous problems. Streams can be completed. That's super important in Rx. Just in here, we take the first element, streams are completed, they're done, they're cleaned up. And why is that important is because, remember I talked about memory leaks. Rx cleans up everything for you. Once a stream is completed, it's cleaned up, it doesn't leak. It happens magically. You can use take until, like say you have two streams of events, and you take events from the first stream until you get something from the second stream. It could be used, for example, in heartbeat, like the client makes a heartbeat to the server until it gets disconnect event, then it stops. Everything else is discarded. Everything is cleaned up, no memory leaks. Works. And this is just the tip of the iceberg. The Rx documentation is huge. There's so many things you can do. You can just read out this documentation like a book for a week, and you're not done yet. And so it's really, really powerful library and paradigm. So don't forget to write some HTML. It's very important when you make a website, always. Now, let's talk about RxJS. RxJS is the library that enables you to do reactive programming in JavaScript. There are other libraries out there, but RxJS is the one we used, and in our opinion, it's the best there is. It has huge community support. It's mature, like very mature. You don't have to fear of the regular JavaScript library bugs that you get everywhere. And it's cross-platform. It's not only in JavaScript, it's also on Scala, Java, Ruby, Python, C#. So it started out in C#, and then community just dragged it all over the place. And in Rx, streams are called observables because they are being observed. So in this case, we take a stream of a single string. And even though we know that it only returns a single string, it returns a collection of single string. A collection of one item is still a collection. So we can treat it as an array. Doesn't matter to us. The functions listening on events are called observers. So in this case, we have an observer. We make a request to the server with to get the JSON with the URI we just defined. And the observer has on next, on error, on completed, the standard protocol. And you subscribe to observables to listen for events. And once you subscribe, the entire chain just starts running. So some of you may have been listening to this and say that, Stenver, why are you talking about this Rx and asynchronous stuff? We already have a solution for that. Why not just use promises? Promises are great. You can chain promises together. You can use the tens. You have unfulfilled. You have unrejected. And they're really, really good tools. They're basically, they have guaranteed one callback call, either fulfilled or rejected. So you don't have any weird side effects. All the handlers are called asynchronously, so you can do all your asynchronous operations nicely away. And once a promise is settled, it will always return that value, which means that if you want to make a new request, you make a new promise. If you want to use the old value, you can use the old promise. So they're excellent tools for these asynchronous problems. For example, let's say we have a team viewer application, and we want to check that if one side clicks on an element, it's clickable, and if it is, then we send it to the other participant. This is how you could do it with promises. Listen for clicks, check clickable element, send click to the other participant. Will work very nicely. However, promises are not perfect. For example, how do you cancel a promise? Let's say user starts downloading a big picture, but then he doesn't want to see it anymore for whatever reason, and you need to cancel it. Now you need to figure out your own way to hide that picture or to stop that picture from showing up, which again can be pretty brittle. And there are ways, there are libraries which help patch that hole in promises, but it's not out there. And the new version of promises will have canceling, but it's not out yet. So other thing is, what if I don't care about the return value? Maybe our click was actually double click, and we don't care about the single click return value. We can't stop that with promises. We again need to build our own solution around that to make that happen, which again can be brittle and hard to do. And finally, the most important, what if multiple values are returned, especially through time? You can return stuff in an array and buffer them or something like that, but it's still putting a pretty big patch on a problem that that's just for a tool that's not meant to be solved with that problem. Promises are meant to be solved with single values, like if you have a single value request, then promises are great. If you have multiple values, then you need something else, like observables. But let's check out this Ajax request example we had before. In here we have onNext and onError. It's actually everything that the promise specification wants. Turns out that if you really look around and start learning, then observables are basically just a promise with single emitted, or rather a promise is simply an observable with a single emitted value. And observable is actually just a promise plus plus. It has everything that promise does, and it has some extra. In fact, you can write this entire thing up here like this: observable from promise get JSON. And Rx is actually meant to be used with promises. You shouldn't choose one tool or another. You should use both tools whenever one is needed. Whenever you have a single value, use promises. Whenever you have multiple values, use observables. And they work interchangeably. Rx has great tools to make them work together. So taking this same example, we can also treat the result as collection. Even though we know that the promise will return as only a single value, it's still a collection, which means we can use map on it. We can use all the collection methods on it that we usually use on collections. We don't need to change the way we program. We can just use regular functional approaches and keep doing the same things we did before. So that's really nice. And finally, we can cancel streams. So that's also something that promises provide. Now, I've been telling you a lot of theory and explaining, and you guys probably want to see some code, right? So let's say you have a stream of double-click events, or you want to have. And let's also say that if you have 3 or more clicks, those also need to count as double clicks. Now, how would you do that in traditional imperative and stateful fashion? Any ideas? Huh? Integrals? Intervals. Yes, something like that maybe might work. Or maybe using timeouts, state callbacks, stuff like that. And I'm not sure how easy the either intervals or the other thing will be to test. Probably quite hard, right? With observables, you could write this entire thing like that. Listen for clicks, buffer the clicks, throttle the clicks so you make sure there's a small pause, then get the length of all the buffers you have, and only keep those that are larger or equal to 2. In case the code is a bit alien because you haven't gotten used to the syntax yet, here's the same thing in graph. At the top, we have a stream of events coming in. We buffer those events, and we throttle them. We need to make the throttling means that there must be 250 millisecond pause, and we buffer all those events together. The second row gives us these grouped events. Then we get the length of each group. We have 1, 2, 1, 2, 3, and we filter out those that match our criteria. Done. Small, simple, logical. The other thing is that let's say you have a mouse move handler, and you want to console log out all the coordinates or events whenever the user's mouse moves. And you want to stop doing that when the user clicks with his mouse. One way you could do that is have the mouse move handler set, and then have a mouse click handler which unsubscribes from everything. You might forget to do like click unsubscription, which will cause a memory leak. And the code itself is quite ugly. You have to read up and down. It's not unidirectional. With Rx, you could do the same thing like this. You take from mouse moves, for each mouse move, console log it out. Then you start listening to clicks. You take the first click and dispose them. The take one disposes the click stream. This one disposes smooth stream. All the memory leaks are gone. It's simple to read, easy to understand. Now, this might look quite complex. You can actually simplify this a lot. You can write the same thing like that. From mouse moves, take until click, console log out each move. Once the click comes, all the streams, we have 2 streams in here, mouse move and click streams, are done. They're completed, cleaned up. We don't have any memory leaks. The code is simple to read, short, easy to understand. Here's another cool example. From the beginning of the talk, I showed you this engagement, prepare media, and preload DOM thing. Really long and hard to read code. Well, not hard, but at least in a short presentation. We can write this entire thing like this with observables. Have a DOM preloader, start preloading, take until we have a hangout clicked, combine it with media detector, and make it into one big event, and take the first one. After that, we're done. We subscribe to it and start the engagement. So you can see how all these flows can become a lot shorter and easier simply by using the reactive programming approach. And very important thing is that they're always testable. But I'm going to get to that a bit later. First of all, there's been a lot of hard code in here. So just a small thing to wake you guys up. What do you think is an empty array plus an empty array? Huh? No? Obviously, it's a string. What do you guys think an empty array plus an object will be? A type error would make sense, right? No, it's an object. But since this is a plus sign, we can, of course, turn this around, right? Of course. Also, what do you think this will return? Of course, it's false. Makes sense, right? This was inspired by a short talk by Gary Bernhardt in Codemash. It's like a 3-minute video. I really suggest you watch it. It's super fun. OK, back to the hard part. Let's talk about testing. So Rx provides you great tools to do testing. It actually lets you do asynchronous testing in synchronous way. What this means is basically before you had these stupid done things in init blocks at the end, and in general they used to be flaky. Maybe the environment was slow or something. Then you had timeouts and stuff like that. Testing asynchronous stuff is really, really hard. Rx makes it possible to do it in synchronous way. And it gives you this thing called test scheduler, which lets you emulate time. And this means that you can actually scroll time forward, backward, and all in a synchronous fashion. It also gives you stuff to make sure do the assertions. And the most important thing, it works with any JavaScript framework. What this means is that basically it's a simple library. You can use Mocha, Jasmine, Jest, I don't know, whatever you prefer. And you just include their testing library, and you can do their testing of their Rx with it. It's really nice. Here's a small example of testing. So in this case, we create a hot observable and fire some events. We fire A at 100 milliseconds, B at 200, etc. It goes down. And we complete the stream after 500 milliseconds. Then we have a start scheduler, which basically, this is our testing scheduler. We take the event stream, we buffer the stream, we debounce all the events 100 milliseconds, we map over the events and join them together with commas. We created the stream at 50 milliseconds, we started the stream at 150, we disposed it at 600 milliseconds. Now, we simply need to assert, basically, the first event A was disposed. We didn't get it because our stream was started at 150. A fired at 100, so that's gone. B, C, D, they all have only 50 millisecond pause. Our defined buffer debouncing was 100. So basically, they all will be grouped together, joined together, and we say that at 400 we get BCD because we need to wait 100 milliseconds after the last event. Then we take the E, and at 500 our stream is completed. The last event is fired. It's done. So it makes it possible to do this complex asynchronous timely events and test them in synchronous fashion. Really nice. Another big thing is called marble testing. In RX5, which is coming out right now, basically, you can already use it if you want. There's something called marble testing. And basically, if you love those diagrams, for example, this diagram, then you can also write tests the same way that the diagrams look. You can even let the tests generate the diagrams. So in this case, we have events, and we have another stream that just needs to debounce it. And it makes sure they're already familiar debouncing that we wait some time until new event comes out. With test, we could write it as such. We have a cold observable, or hot observable, sorry, that fires events. We have the debouncing observable, and we say that the hot observable needs to debounce by whatever the cold observable is. And the expected is exactly the same as the bottom. Since we have written it as diagram, this diagram will be generated from the actual test itself. Another example is here the same way. Our streams start at these ticks, and it's basically the same way. We simply merge these two things together, but we can basically write our tests as the same way we had diagrams. So they're a lot simpler to scan through with our eyes, and it's called marble testing. It's really cool stuff. Check it out. Another very important thing about Rx is that it provides you the tools to do debugging. Basically, you can use the do keyword to cause side effects. So in this case, let's say we want to console log out all the clicks and lengths, then we can just use the do keyword, and whatever the result is passed on. The do keyword does no modification to the result. So that makes it really easy to debug your code. There's also lots of other things like timestamps, stacks, and the environment and basically the entire library is constantly evolving and becoming better. And they're giving you all the necessary tools to understand what your code is doing and make it easy to debug asynchronous stuff. That's really nice. So the way we use Rx is that basically observables everywhere. Observables are on server side. The data comes out from the database. It mapped, reduced, filtered, sent to the client. All the operations are done in there on the streams. It comes back again to the server. Again, it's filtered. So it's kind of these streams of data flowing around everywhere in the system. And Rx is not only on JavaScript. It's also used on Java, .NET, Scala. Basically, all the major languages have their implementation of Rx. And you can use it on both server, client side. And if you don't believe me, believe the big players. Angular 2 ships with Rx. React Redux mentions Rx all over the place. At least Redux does. Cycle.js ships with Rx. And companies like Netflix, Microsoft, Asana, Google, and all the other guys are using Rx because they have asynchronous applications. And Rx is the best tool to build those applications with. So that's it from me. Thank you for listening.